Hey, in our last lesson, we talked about flat mirrors, plane mirrors. And today we're going to go on and we're going to talk about curved mirrors. We're going to talk about convex mirrors and concave mirrors. And we're going to talk about how to draw a ray diagram for each of those. And we're going to talk about a couple of formulas where we can find the focal length or the magnification of some of these different mirrors. So today, curved mirrors, and our target is to be able to explain and predict reflections in flat and curved mirrors. So let's go ahead and let's talk about a few things relating to curved mirrors. Okay, first thing to understand about curved mirrors is that there's two kinds of curved mirrors, right? We can have a mirror that curves in, or I don't know if you can see it on the video, but it curves inward, or we can have a mirror that curves outward. Right? Probably can't see it very well on the video. Anyway, one is called convex and the other is called concave, right? The one that curves inward is concave and the one that curves outward is convex. And I always have trouble remembering which is which. The names are pretty similar, but then I thought of a good way to think about it. Let's see, here we have a mirror that curves inward, and I think about a bear. Here's a bear. And ask yourself, can the bear go in the cave? If the bear can go in the cave, then it's concave. If the bear can't go in the cave, then he gets vexed. And it's convex, right? So can the bear go in the cave? If so, it's concave. Like my bear. Okay, if we want to draw ray diagrams and understand what happens to light as it reflects off of a curved mirror, there are a few parts of the mirror that we need to look at and talk about and know what they're called. Okay, so I'm going to put a diagram up here, and this first one is a convex lens, or I'm sorry, a convex mirror, and you can see a few different parts of this diagram here. Okay, first part I want to point out is what's called the principal axis. You can see the mirror there, and you can see a line going right through the middle of the mirror, kind of perpendicular to it. If the mirror was a straight line, it would be perpendicular, but you know what I mean. It's going kind of right through the middle of the mirror, right? This we call the principal axis. And along the principal axis, you're going to find a couple of important points, okay? One point there is what's called the center of curvature. If that mirror was a whole complete circle, then that point, that center of curvature, would be the center of the circle, okay? But that particular point is not the most important point. The most important point is the other point that you see on the principal axis. So it's called the focus. The focus is halfway from the mirror to the center of curvature, okay? And that focus point is gonna help us figure out how light reflects off of the mirror, okay? The focus point is where the rays of light will either focus to or away from, depending on which kind of mirror we're talking about, okay? The next diagram here is a concave lens, or a concave mirror, and you see all the same points. They're just on the other side of the mirror, right? So both the center of curvature and the focus should both be inside the curve. Let's draw a ray diagram for a convex mirror. Okay. When we draw a ray diagram for one of these curved mirrors, what we're going to do first, let's draw the mirror. And we'll just draw a curve, a convex one, curve outward like so. Let's draw it so that it's on camera nicely. Okay. And then we also want to draw the principal axis. Remember, the principal axis kind of just goes straight through the middle of that mirror, like so. Okay. Now what we're going to do is we're going to mark the focus, the focal length, right? And remember, the focus should be inside the curvature. Maybe a problem tells you how far it is from the mirror. For us, just drawing this ray diagram, we're going to put it, let's put it right here. And we'll label it with an F. So we know that's the focal point. Okay, and then what we want to do is we want to draw the object that we're reflecting in the mirror, right? Let's draw a pencil. And since this is the outside of the mirror, this is in front of the mirror, let's draw a pencil over here. And usually what we'll do when we draw one of these for a curved mirror is we'll draw our object so that the bottom of the object sits on the principal axis. So I'm going to draw a pencil, and I will put it right here so that the bottom of my pencil is on the principal axis. Like so. Okay. Now what we're going to do is we're going to draw a couple of lines. Okay, I'm going to get my straight edge, and we're going to draw two lines to see how the light reflects. Bam. Okay, so the first line I'm going to draw, I'm going to go from the top of my object, and I'm just going to go straight across to the mirror. Okay. That line should be parallel to the principal axis. And then from this point where it intersects the mirror, I am going to line it up through the focus. Okay. Now behind the mirror, I'm going to draw this as a dashed line. And then when we come in front of the mirror, it's a solid line. Okay. So that ray of light comes to the mirror and reflects off this way. It will reflect away from the focus, right? So if you were standing over here, it would look like it came from over here, but really it went like this. Okay. The second ray that I'm going to draw, I'm going to line it up from the top of my object to the focus. Okay. And I'm going to draw a solid line to the mirror, and dashed after that. And then from this point where it intersects the mirror, we're going to reflect back parallel to the principal axis. Okay, and let's continue this. Okay, so the first one goes parallel and then away from the focus. The second one goes towards the focus and then parallel. Okay, and you can see where these two lines meet. We're behind the mirror here, where this one meets this one. This point right here is the point in the reflection that corresponds to that point on my object. So here is the image. Okay, this will be the top of the pencil. So now I can come over here and I can draw what the image of the pencil will look like. Just like that. Okay. You'll notice for this kind of convex mirror, you'll notice that my image is smaller than my object, right? You'll notice that it is right side up and not upside down. You'll notice that it's closer to the mirror than my object is. Okay. And since it is behind the mirror, we call this a virtual image. Okay. A virtual image, it's an image that's not really there. It's just a reflection, right? If my image were on the other side of the mirror, we would call it a real image. Let me show you an example of a real image. Okay, I'm over here by the window. And I have here, this is not a convex mirror, this is a concave mirror. And this concave mirror is going to give me a real image, right? What I'm going to do is I'm going to hold this up so that it can reflect light from the window, and I'm going to reflect it onto this paper. And you can already see the blue of the sky outside. And if I get it at just the right distance here, you can probably also see some nice puffy little clouds outside. You can see like the little frame of the window there. You can see a nice image. If you were actually here, the image actually looks better than it does on the camera. Yeah, but this is a real image, right? This is not behind the mirror. This is in front of the mirror. This is being projected from the mirror onto the paper. A real image. Speaking of concave mirrors, let's draw a ray diagram for a concave mirror. We're going to follow all the same rules that we did for the convex mirror. First, let's draw the mirror. Should go this way, should curve inward, and let me draw the principal axis. And we'll identify the focal point. A problem might tell you where it is. We're just going to kind of put it right here. Okay. Now, I'm going to draw my object so that the bottom of the object is on the principal axis. And I'll tell you what, it matters where this object is. If it's over here, we're going to end up with a very different picture than if it's over here, right? So let's just, for example, draw one over here. So I'm going to draw a pencil over here. It could be any kind of object. It doesn't have to be a pencil, but a pencil is nice because it's different on one side than the other. Okay, and now we're going to draw our rays to see, where do they intersect. So the first ray is going to go parallel to the principal axis. And then it's going to go through the focus. You'll notice there's nothing behind the mirror there. Our second ray will go through the focus. And then reflect parallel to the principal axis. There we go. And I should have drawn this line out a bit further, because they intersect right about there. Okay. So here is my object. Here's where the image is going to be. So from the top of the object, this is the top of the image. So let me draw something like this. Okay. Now, you'll notice a couple of things. One, it's upside down, right? This one is upside down. It's also about the same distance from the mirror as the object was, right? It might end up much closer. It might end up further away. This one, just by where I happen to put the focus and where I happen to put the object, just happen to come out about the same distance. And it also looks to be about the same size as well. And this is what we call a real image because it is in front of the mirror. Okay, here I have drawn another ray diagram where the image comes out not in exactly the same place as the object. You can see here is my pencil, and here is its image. It's much smaller, it's upside down, it's closer to the mirror, right? And I've labeled some parts here. You can see the object distance, the distance from the mirror to the object, I've labeled as P. The image distance, the distance from the image to the mirror, I've labeled as Q. The height of the object, I've labeled as H. And the height of the image, I've labeled as H prime. Okay? And there's a couple of things that we can, predict using math about these ray diagrams, right? First, there's a relationship between the focal length. You see, I've labeled the distance between the focus and the mirror as F. 1 over the focal length is equal to 1 over the object distance plus 1 over the image distance. So if we know two of these three things, like it's fairly easy to know the focal distance and the object distance, we can easily predict the image distance. Or if we know any two of them, we can predict the third one, right? The other thing that we can predict is what's called the magnification, right? Some mirrors magnify. So like this particular type of mirror, if I had drawn the pencil on this side of the focus, it would magnify the image, would make it bigger, right? If I draw it outside the focus, it makes the image smaller, right? So we can talk about its magnification fairly easily, right? The magnification would be the height of the image divided by the height of the object. Or alternatively, you could take negative the image distance divided by the object distance. So, there's some stuff that we can do mathematically with this. Let's go ahead and take a look at a problem where it's going to ask us to use this. All right, let's have a look here. It says a concave mirror has a focal length of 10.0 centimeters. Locate the image of a pencil that's placed upright 30 centimeters from the mirror, and then find the magnification. So when it says locate the image, it's asking me to find the image distance. So like we just talked about, 1 over the focal length is 1 over the object distance plus 1 over the image distance. It's asking us to find the image distance. Okay. So now it told me that the focal length is 10 centimeters. I can just choose to work in centimeters on these problems. I don't have to change it to meters. So let's say 1 over 10 centimeters is equal to, it told me the object distance was 30 centimeters. 1 over 30 centimeters plus 1 over the image distance. Okay, now I have to remember how to work with fractions now, right? What I'm going to do is I'm going to subtract this to the other side to try and get my variable by itself, right? So I'm going to do 1 over 10 minus 1 over 30 equals 1 over q. And then, of course, to subtract these, I need a common denominator. So I'm going to multiply this fraction by 3 over 3, and that'll make this 30. So I have 3 over 30 minus 1 over 30 equals 1 over q. Now I can subtract. So 3 minus 1 gives me 2 over 30 equals 1 over q. Let me do the reciprocal of both sides. So that'll give me here q equals 30 over 2, which is of course 15, right? So q, can we still see this on the camera? Maybe. I'll write it over here. So q is 15, and I need 3 significant figures, so I'm going to put 15.0. And that was in centimeters. There we go. And then it also asked us to find the magnification, right? So what's the magnification of the image? So I'm going to erase this problem here. The magnification, if you remember we just looked at a minute ago, is either the image height over the object height or the image distance over the object distance there. Okay. Well, I don't know the heights, but I do know the distances. So let's go with this right here. So the magnification, okay, Q is the image distance. We just found out that was 15 centimeters. P was the object distance, which the problem told me was 30 centimeters. And then, of course, 15 divided by 30 is a half. So the magnification is a half. There's no unit to put on that. It's just how many times it magnifies. So this one magnifies a half times. Not too tough. So there's a little bit about curved mirrors. So now we've talked about flat mirrors, we've talked about curved mirrors, and hopefully that helps us to be able to explain and predict reflections in flat and curved mirrors. So till next time.